All right, let me show you as we graph these, let me show you what they look like. So exponential growths have this invisible boundary that keep them from going further than a certain point. And as you start to graph them, you'll really see what it is. Let me show you what it looks like. This is an exponential growth. Do you see how the purple's kind of hugging the axis there? Gavin, put that up. Right?
I got it. I do that. My grade just went up.
Put it up unless you want to lose it. Okay, not relevant, not relevant. This is what growth looks like, okay? So what we're going to do is we're going to graph, we're going to make a T-chart, a table from a rule or an equation written, and then we're just going to plot the points and graph it, all right? But I want you to see what it looks like. It could be slid over some more. So maybe it's over here. Right now, for today, for our benefit right now, oh no, all of our little boundaries are going to be right here on the x-axis. Okay, that's the point they're not going to go. They can also flip under, and they can look like this. That's still a growth, okay? But just know it's not going to pass over that axis. So we're just going to pick some points, probably -2, -1, 0, 1, and 2, just like we've done before. Plug them in and find where they are. What you mean? There are. That's when we start adding some things to the equation. Whenever, not yet. Not this one yet. Okay. All right, look at this one. All right, so what I want to do, I want to make a T-chart, okay? I want an X and a Y. I would do always -2, -1, 0, 1, and 2. Those are good base numbers to start with for these kind of problems. All right. So, let's plug in first. Let's plug in -2.
What? You didn't even put no. Oh, we're trying to figure out why.
What's y when x is -2? Well, when x is -2, watch, you're going to have to use these exponent properties. Guys, I need you here. This is where it gets hard, okay? Exponents come first. What is 2 to the -2? What does a negative exponent do? Turns it into a fraction and turns positive. So this becomes 3 times 1 over 2 to the second. And it is 4, but it's 1 over 4. So it's 3 times 1 over 4. What is 3 times 1 over 4?
1.
It's 3 over 4.
I was thinking of adding.
How you get this stuff? I ain't lying. Oh, you over there
Look, look. I just plugged it in.
Okay, don't understand. Okay, do that.
Look, you can put it over 1 as top times top and bottom times bottom.
That's not what I'm talking about.
What are you talking about?
How do you get there?
All right, to anything to the negative exponent. Remember, you have to make it positive and move it.
Oh, you put that 2 on.
Uh-huh. 2 to the -2 is the same thing as 1 over 2 to the second. Make it positive and move it, remember? I mean, it could, but...
Oh, you flipped it upside down. Okay, I got it.
Woo!
I just upside down.
All right, let's do... Where the what? So when you flipped it, you got 1 over 2 to the second. 2 to the second power is 4. Because 2 times 2 is 4. All right, same process for -1. The negatives are going to be the hardest. This is going to happen every single negative. Okay? Just a graph. Look, 3 times 2 to the -1. Okay? The negative makes it flip. So what does that become? 1 over 2. And 3 times 1/2 is 3 over 2. 3 over 2 is 1 1/2. Okay? I'm going to show you how to graph it. Don't worry. Right now, let's fill in our t-chart, okay? 0, when y is 0. I mean, when, yeah, x is 0, sorry. 3 times 2 to the 0. Well, this is easy because 2 to the 0 is 1, and 3 times 1 is, everybody saying it, 3. Now it should get easier. The positive exponents get a lot easier, right? Because there's no flipping. Y'all find 1 and 2. Y'all find 1 and 2 on your own and come back and let's see if we get the same thing. Plug in 1 and plug in 2. Each one of them, the rule's already right there. That's right. So you know that each one is being multiplied by 2. That's your B, right? I'm going to graph this. Here we go. It's not as hard as you think. Because I know how high up it's going to go. It's going to go up to 12. I need enough room.
Whoa.
-1, -2, 1 and 2. 1, 2, 3, 4, 5, 6. All right, watch, because some of you said you're confused about how you graph with these fractions. 3/4 is the same thing as 0.75. If you put it on your calculator, you will find that, okay? That's not quite up to 1. So I go -2 and up to almost 1. This is the point, -2, 0.75. So over 2, 0.75 is not 1, but it's close to 1, right? It's 3/4 of the way up. So go up to almost 1, but not quite. Some more, put that up before I take it. I know. Now the next point is -1, 3/2. 3/2 is 1.5, which is 1.5, right?
Yeah.
So look, -1, and then I go up 1.5. The rest of them are easy because they're whole numbers. 0, 0, 3, 1, 6, and 2, 12. Do you see the shape? Okay. It's going up here. I missed the whole point. And it's coming around and hugging this line. Let's do one more. Let's do one that looks a little different. All right. Let's set up our All right, so somebody asked earlier, do I have to go -2? If I'm good if you want to just do one negative, but at least have one negative on there for me, okay? So if you want to start at -1 instead of -2,
And at least how?
and go up to 2. Yeah. Okay. The negatives are the hardest to work with, and that is when you're going to get into your fractions, okay? But I need to make sure you can at least understand that and what it's going to do. All right, so when I plug -1 in, -1/2 times 2 to the -1. Remember, you have to remember negative exponents don't make a negative number. Negative exponents only flip that number. Okay, so this is -1/2 times what? 1/2. So it's -1/, what's 2 times 2? 4. -1/. Only when I flipped the 2 because the exponent was negative. Okay. Okay. That should be your hardest one from there. It should be easier. Okay. Because now when I plug in 0, 2 to the 0 power is what? So I get -1/2 times 1. Yep. Plug in 1 and see what you get. This one, remember I told you it could be above the axis or below? This one's going to be below. This number in front, this number, if it's negative, it's below. If it's positive, it's above. What?
Oh, my bad. Right there. Okay.
That's right, -2. All right, so Kennedy was just asking about why they're all negative, and I was explaining to her that, remember, the growth can be above that axis or it can be below that axis. And because that first number is negative, that tells me it's going to be below that axis. And that's okay. It's really okay. Let's graph it. I'm going to space my lines out a good bit because my lowest point's -2, so you can really see what's going on here. All right, so my first point is -1, -1/4, right? Huh? 2 to the second power is 4. So I put it over 1. 4 divided by 2 is 2. It is, so you do top times top, bottom times bottom, and that simplifies to 2. All right, -1 1/4, so I'm going to go over 1, and I'm just going to go down a little. 1/4. So 1/4 of the way down. If you divided this into 4s, that's how far down you go. 0 1/2, so here's 0, and I'm going to go halfway between 0 and 1. If you're going to space these out, it's a little easier to graph. 1 -1, and then 2 -2. Do you see it? It's not the best, but yeah, it's kind of like that. What you think?